outside the room. Thank you.
Oh, it was us. It was us. You know, it was too good for people to leave. It was us.
Yeah, kick the transport people off.
Afternoon, folks. So we'll get started in about 2 minutes. Just wait for people to stragglers to come in here. Okay, the doors are closed. You're all stuck in here, and we'll get started. So welcome, SFC working group. I just want to bring up the normal note well. Make sure you've read that and understood the all of the different things here. In terms of the agenda, we're going to give a quick update on the security design team that we started a couple of IETFs ago to go and look at what aspects of security we need to take care of in SFC. So we'll talk about that. We also have some discussion on OEM, another area that we need to make progress on in the working group. We'll also talk about the hierarchical SFC. There's been a lot of work going on there. So we'll get an update on where they're at. And then some discussion about another draft that has raised a lot of interest, which is to do with generating packets from a service function into a service chain. So more detail on the agenda here. I'm not going to waste time going through this, but we'll just get cracking. So our first discussion is for security on service function chaining. My co-chair Martin has been working on this, and we started a design team to look at, what do we need to do in SFC from a security standpoint, and this is an update on where we're at. One of the things that the chairs are keen to do, obviously, is to move this work forward. It's obviously an important area of our discussions, but at the same time, we want to make sure that we don't hold up any of our existing work. Notably, we've been doing a lot of work on the SFC encapsulation. I'll talk about that in a second and where we're at. And I'd like to get feedback from the working group on these specific security drafts that we have and what's missing and what we need to do moving forward. We basically need to try and find a plan to move this forward. So these are Martin's slides, so I apologize. I'll go through them as best I can. Just some history. So the IESG review for the two RFCs that we have so far, which is the problem statement and the architecture, raised some concerns. There was some concern that perhaps security had not been covered as deeply as it should. So we formed a design team to do an SFC security analysis, and that was at IETF 93. And a couple of drafts came out of that. I've listed them there. Can I get a show of hands as to how many people in this room have read those drafts? Okay, not many. So the first point from the chairs is really encourage people to go and read those and give feedback to the working group on the work that's been done so far. The second thing is there's also a draft that was created to look at authentication and encryption of service chains. Again, it's separate to the design team, but obviously an important piece of work. Again, I encourage people to go away and read that and provide feedback on that as well. So where are we at today? So basically, the discussion on SF security basically didn't progress very far apart from the design team. We've really had we haven't seen a lot of real discussion within the working group, whether that be during the meetings, these face-to-face meetings, or on the working group list either. There was a bit of discussion at IETF 94, but that security topic is really not progressing, and the reason for bringing this up is that we really need to make progress there. So this is where we're at from Martin's perspective. We're at the depression stage where we're looking at security and saying, well, what do we need to do with this thing? What we are trying very hard to do is not hold up other pieces of work. And if we need to, work on security and publish some documents on that, we need to do that in parallel to the other things that we're doing. The one that's on my mind specifically is the SFC encapsulation. We've done a lot of work on that. It went into the working group last call, and we had a lot of comments come back. It's my understanding from the editors that we'll be getting a new version of that document either next week or the week after that hopefully addresses the comments and concerns that came out of that working group last call discussion. So again, I really encourage the working group to go and read that document once it comes out, because we want to get that to the IESG in a state that can move the encapsulation forward. Once we get that encapsulation as a working group, we're in pretty good shape because in terms of our milestones. There's a lot of other work to be done, which is the security in the OEM and some other things as well in the metadata discussion, but we want to move that forward. So how do we fix this and move to acceptance? We've basically in the architecture document, we've got some very high-level security considerations that talk about boundaries and classification and the encapsulation. We have the two documents that I already mentioned that talk about the threat analysis and the first set of requirements. But again, this needs fleshing out and needs some work. I'm not going to go through all of these. I'll let you review these slides. What I'd like to do is open up the mic to get any comments on the SFC security topic that's on people's minds. Any comments on how you think we should move this forward? Any comments on what you feel is missing? So please feel free to have that discussion now.
Oh yeah, Atlas, since I'm not seeing anyone else coming up. Look, let me be blunt. I understand that a lot of the historic service function chaining being done with VLANs in very isolated environments where security and privacy hasn't been a consideration. And there are a number of ways of addressing security and privacy that are not talking about, oh my gosh, you encrypt the whole thing forever, everywhere, and which a lot of people are not excited about, right? There are everything from, gee, we're deploying it in this particular environment and that's why it's not an issue, to we only have to worry about privacy, privacy identifying metadata, and this is how we handle it. We can obscure it by using indirection, and you need to talk to the orchestrator or control plane in order to have learned it. There are a lot of ways of doing it, but the one thing we can't do, if you'd like any of the work in this working group to go forward, is ignore the question. So if we're not having a conversation now, and this is what face-to-face time is for, is having a conversation about these types of things, then when are we going to have that conversation? Thank you.
Yeah. Carlos.
Hello. Carlos Pignataro, Cisco Systems. So a few IETFs ago, we raised this issue about security in SFC as a general comment with Aliyah. as part of advancing the architecture. And at that time, we formed the design team. That design team produced a couple of documents, which are, a fairly broad view into what security is. I think, however, that there's two separate pieces. One is the protocol that we're advancing now as a working group, which is the realization of the architecture, and that's the NSH. Second one is this more holistic view of, all things security and the working group. And I think, trying to think of these two things separately, I agree that the NSH document needs, tightening in the security considerations, non-insignificant additional text regarding, for example, personal identifiable information and things we bleed into the metadata. I would like to decouple that conversation from, the product of the design team. And the real question that I have here for the working group is, we as a group, what do we want to do with that work, right? So the design team was formed. There's something for us as a working group to work. What do we want to do with it, right? And again, decoupling that question from the NSH.
Mm-hmm. Does anybody else have comments? I mean, this must be it's an important topic, so let's not be shy and let's speak up, please.
Okay, Joel Halpern with Ericsson. I've been active here a long time. I've looked again just to make sure at the two drafts from the design team. They seem to do a good job of capturing the compromises we are faced with in the realities. They lay out the issues that need to be addressed and the context in which it makes sense to take additional steps to do them. I believe we can craft solutions within the structure of things we have adopted that meet those drafts as they are written. So I think they are a very good step towards this. Whether the ISG as a whole will consider them acceptable is a question I'm in no position to comment on.
Oh yeah, so Joel, they may be fine starts, but with NSH, we can't have the security section refer to requirements. It has to refer to solutions.
Diego Lopez. That's for me that I'm taking notes, but then I have to
Just remember what you said.
Okay, so Diego Lopez, Telefónica. First of all, just to express my agreement, I think that what the design team has produced is very valuable, and I will even go and start going for adoption or even further as a base work for security, but we need to address those requirements. And and just a note to something that probably has been overlooked as well. It's true that, as Alia was saying, the SFC is going to happen in a very restricted environment, so security is something that in some cases, but there is a particular thing that I got some time ago, a request from some potential users from application environment that is very sensitive to security precisely. And it was about how to guarantee that a path in a certain chain has been actually executed.
Yep.
Which is a matter of well, for them it was a key requirement. We have been discussing a little bit this with, but we have to elaborate it as a draft. I'm not so in a certain moment probably we will come with a draft on this because we have been doing some work. That's for that moment that we were trying to validate with these guys before coming. So, but again, probably going for encrypting everything and all the like will be in this environment overkilling. But it's true that precisely this assurance and well, it would go further. Accountability is essential. Something that we have to address one way. The sooner the better.
Okay. Yeah, on the verification, that's actually one of the presentations is going to talk about that, so you'll be pleased to hear about that. Any other comments? So I think from my perspective, I would echo what Carlos said. We do need to tighten up the security considerations in the SFC encapsulation document. That certainly needs to be done. What I'm very keen to do is not, hold that work up for the security. We need to make sure that we've got enough in that document, though, to cover what the IESG needs. But I'm very also keen to make sure that as a working group, we don't, as Leah said, ignore the security question. And so we need to take those documents that we have already and really work out as a working group where we want to move that forward. So I think what's going to happen is Martin, my co-chair, is this is an area that he wants to focus on. So we can probably expect to see some interim discussions on that very topic and start moving that forward. What I'd like to see at the next IETF meeting is a good summary of a good plan on what we're doing as a working group from the security angle. No more comments, huh?
It's Dave Dolson. So far, it doesn't appear that we've standardized any metadata. Seems like that might be a good place to discuss specific issues with specific metadata.
Mm-hmm.
So, if metadata is about what time the packet arrived, probably doesn't have the same kind of security considerations as whose packet it is.
Yeah.
So they might be able to deal with, security issues related to the path ID and the index, and which is probably a lot different than subscriber.
Yeah, and I think they're separate topics because, in the SFC encapsulation, it's very descriptive that the metadata is opaque, which means that, when we do the metadata, that's if we standardize any of that, that's a separate thing to the base encapsulation. So, I agree. That may be an area that we definitely need to focus on more from a security standpoint when we get to that metadata aspect.
Yeah, Leah, there's definitely differences in terms of the metadata, and it's a possibility to have different requirements for different types or different environments, and I'm certainly happy to suggest that you send the NSH document when you think it's ready to get a security directorate review early so you can get a sense of the types of issues that will come up.
Yeah.
I'd just like to emphasize, we started the design team, we got this going a year ago, okay? If we want to move quickly, we actually have to do the solutions.
Ramki Krishnan, Delft. So just to kind of add to the discussions, what I also think personally is that the NSH header issue needs to be decoupled from the overall security issue. The key reason is the service chaining solution today can be accomplished simply without NSH. It's simply possible. So if you decouple and then just say, hey, in the NSH draft, what are the security issues due to the addition of NSH, then that would probably help resolve the issue.
Yeah.
Just my thoughts.
Mm-hmm. Thank you. Any more comments, or can we close the topic?
So, for security, Uri, so Intel, for security reasons, I'm scratching my head whether it's better to keep my mouth shut or actually ask questions, because I'm really puzzled at this point as to the way forward. So we had a design team. The design team came up with a document. The document originally was by far, I think, the work group comments was too restrictive on one end, or maybe focusing too much on an environment where somebody cannot really guarantee any security. Then we all agreed that what we are going to do next was to say yes, but in many cases we are going to deploy an environment where security could be administered in other measures, and that would put this draft on grounds that is not specifically different from many other efforts. And therefore, we really just need to look into those aspects that are specific to NSH and just have those written down. And now I hear we are still kind of somewhere in that no man's land between the security team and the draft they had, which has all sorts of general good advice, to what we really want to go document inside NSH, which to everybody, I think at this point, as an example, does not include control plane, because we want to make separate progress on the data plane and have separate conversation on the control plane, and we don't want to couple them. So what I would like to make sure we get out of the meeting here, so that we don't repeat the same conversation in 3 months or whatever, is something a little bit more concrete and specific that says, this is what we all think is the minimum we need to put in NSH.
Yeah.
Oh, yeah. So, yeah, I hear you. And it was good to hear several people say that they liked what the security design team had produced, but I haven't seen significant conversation about it. Currently, the NSH draft refers to requirements on security, which isn't sufficient. It also talks about metadata as being completely opaque, and you don't have to be imagining the worst to understand that it can and probably will be personally identifiable information in that. So you need to have some document that talks about the environment and how personally identifiable information can be handled, talks about, you know, translating it to a cookie which gets passed around by control planes. There's a number of different ways to solve it. I'm not trying to tell the working group in any way how to solve it. I'm saying that we need to actually have the discussion to figure it out actively. And I mean, I'm perfectly happy to take anything that's reasonable to discuss with the ISG and to move it forward. This isn't about you doing what they're saying is necessary or what I think is necessary. This is about you doing anything that's in there, okay? That's a vaguely plausible, defensible, here we've thought about it. And my impression last meeting was that people were not overwhelmingly in agreement that the design team had captured everything perfectly. And so I was very disappointed not to see discussion about it. And I feel like we really need to have it. We've had a lot of really excellent discussion about terminology and other minutia, but this is a really important topic to actually nail down.
Joel Halpern again. I'm sorry, Aaliyah, but some of what you're asking for doesn't belong in this document. No, but some of it belongs in a document that this document should not even depend upon. So what she said, because she didn't have the mic, was reference some other document. We can put things in a separate document, but that still creates a dependence chain and a slowdown. And we maybe needed to slow some things down. But, for example, a discussion of whether specific kinds of metadata should be represented by cookies or should be hashed or any other thing doesn't belong in the base NSH document because it can't deal with that in any detail. We put the face pointer on that, Carlos and I, in the architecture document. We said personal identifiable information, when practical, needs to be represented indirectly. And that's already there. We can point to the architecture document, but it doesn't add anything to do that. There are people working on ways to extend NSH so we can do various security mechanisms when it's needed. But the very common case, we don't need it. And I'm really uncomfortable with your saying, we need to work out the solutions, which is what you said, when for most of the work we don't. Now I understand the security guys really don't like bolted on security, but this isn't bolted on security. We've got an extensibility mechanism, which one of its many design properties is we believe it really can handle the security needs for many cases. Now, it's going to probably drive more folks to having to do MD2, which doesn't bother me because I think that's the one we need for a lot of cases. So fine. And maybe MD1 can't be used in cases where you need security. Okay, that doesn't bother me either. But I can't see NSH as a document specifying that in any meaningful fashion. So I'm really left confused about what we need to do to be able to advance the NSH document. I clearly agree we need to work on these other pieces, but at the same time, I'm very worried there are some specific issues like specifying that the TLVs are in 4-byte chunks was a mistake. We got to fix it. A few other things. You pointed out a bunch of things we got to clarify. We got to do that. But on this issue, I am unable to parse what you're asking for. I'm sorry.
Okay, so you're right, Joel. The architecture says that, and the NSH document says, oh, here are some requirements, and we're not thinking about security other than the requirements. You might say, although metadata is opaque here for these purposes, I mean, you could say the assumption is this metadata is not personally identifiable. If there is more, that will be handled when we define specific metadata and mechanisms. You could say this is being deployed in a closed environment, and therefore these are the environmental around that we think it's not going to be an issue. You can't refer to a requirements document as the only gunk stuff in there. I mean, I can talk to you offline.
Carlos Pignataro, Cisco. I was actually going to say something fairly similar to what Joel said, and I want to probably try to double click on it and take it a little bit more real. The NSH document concerns itself with specifying a data plane, and it doesn't even define which types of metadata are actually carried within that NSH, right? So like Dave Dawson said earlier, specifying security considerations regarding the SPI is something that is missing, and it needs to be added. However, when you say, Alia, we need to work on beyond these requirements, I think you're right, but that's within the context of the working group, not necessarily within the context of the NSH, which doesn't concern itself with defining which type of metadata and doesn't concern itself with the control plane considerations.
Yes.
Thank you.
Sorry, Carlos, yes, the concern is defining some of the scope or making it clear when the concerning metadata would be defined. The issue is, you could say that we need to have thought enough about that I could say it's not bolted on security, okay, that we understand how to handle it for future pieces. And that's the issue, right? You need to be able to, we need to have something enough in the NSH document, enough, hopefully, work, and maybe it's just the cookies type of approach that we took in the architecture, maybe it's something more, but to have that piece thought out, not completed, but thought out enough that it's clear that we don't need to put something in, it's not, how do we bolt it on later? And yeah, I mean, the timing sucks, I'm sorry, I tried to get this going a year ago. I mean,
what you describe at the high level sounds reasonable, but again, I wanted to double click on it to make sure we understand which parts belong in NSH and on the SFC data plane encapsulation versus which parts belong in a different place, right? That's basically my comment.
yes, and I don't want to try and write what the security section should say here. I think there's two pieces. One is we've got to have some understanding about security around the metadata, and that's the working group moving forward in that space. So we're sure that we have a solution that doesn't require changing NSH. And that's the gotcha, right? And then the other part is having the NSH document talk about either, something around the metadata, or, having some words in there about environments, about what kind of metadata is possible in the clear, those types of things, so that it's clear that there's actually been thought about it. I mean, it's something we could talk with the security design team here. We can get a security directorate review of that section. I don't think a random security directorate review will be nearly as valuable as talking to the design team, because they won't have all the context. My hope was to pull more security folks into having enough context to have a meaningful discussion. But that's the kind of, basically, I want to know that it's clear NSH won't have to change when we look at the security pieces. That's really what I'm looking for when talking about solutions.
Yeah, so thank you. I think we're saying the same thing. I stood up there and said security is important, and I agree that, the tech that exists right now needs to grow significantly within the NSH. I just wanted to put boundaries on what's expected from the data plane encapsulation document.
I'm happy to bring it when it has something plausible. I'm not trying to say what it is, and I'm not trying to say that we need to do all of the related work for all types of metadata in all types of environments, but it's got to have something plausible.
So we need to move on, but I think, Aaliyah, what we can do, as I mentioned earlier, that there's going to be a new version of the NSH document or the SFC encapsulation document either next week or the week after. My suggestion would be that we get together with the design team, we'll go through that security considerations section, see what we're missing, and we'll take it from there. One more comment. Yeah.
So I think we are, what I hear so far, we are exactly on the same page when it comes to issues of those elements of the data plane that the NSH has to deal with directly, i.e. SI and SPI. That is absolutely part of the core processing that the data plane is doing, has to be dealt inside the document. I think where things become a little bit fuzzier is with the fuzzy metadata, because that is not clear what is really the entity in the overall architecture that owns that. Should that be stopped somewhere at the edge? Every element can create that, so who actually owns that? And what are the mechanisms we want to put around it? Because one mistake we could do is to put two onerous mechanisms in the data plane, and that is not going to be good for anyone. So we need to balance between your concern that we didn't address it and therefore we'll have some bad news later, to doing too much right now on something that really is not part of the data plane. So that is a challenge we have.
Okay. Okay, so we move on. I'm actually going to make a slight adjustment to the agenda because I know Frank has a hard stop, so I really need to get him up. So I'm just switching the OEM subjects around. So Frank, I don't know if you can present the proof of transit and the inbound OEM. Just tell me when you want me to switch slides and I'll finger it up here. There should be one here. Yep, there you go. Does it work? I don't know, we'll see.
Yeah, that one works. Does it work by now?
Does that
Can
work?
you hear me? All right, good.
There's one there. Try that one.
Does that one work? Yeah, right, that's far better. Yeah, thanks, Jim, and appreciate the flexibility. So if you fast forward next slide, so this is work with a bunch of co-workers. We do service training for quite a bit. If you go back to the problem statement, we do service training for quite a bit, but have we ever asked ourselves whether the packets actually follow the path that we steer them towards? i.e., have we ever asked ourselves whether all the packets follow that path? We don't know, right? And I'll be happy to kind of address that particular topic once we're through the presentation. So let's give it another 10 minutes, and then we can discuss the overall thing in one block. So we were asked that very question by a financial customer around about 2 years ago. where he said, well, if we go from the physical world to the virtual world, this problem becomes even harder. In the physical world, we might be able to prove by checking cabling, putting probes into the cables, and see whether every single flow is making it through the entire service chain or the likes. If you go to the virtual world, a single misconfiguration of the V-switch might actually make you bypass a particular function. And the particular function is not necessarily only to the SFC architecture, it might be something else, it might be just following a path, right? And you want that the traffic makes it through a sequence of firewalls. So a solution approach for that is, well, if you want to go make sure, if you fast forward to the next slide, well, you want to go check that all the traffic is making it through it, you've got to go check every single packet. And that check-in is typically in a way that there is some trust domain that you want to go verify, and there is a verification domain. And these two domains should be separate, typically run by separate teams. So there is one team that wants to do with the verification and one team that needs to go do the operation. So what we want to go do is, the upper path is the correct one, and the lower path is probably not the correct one, and we need to find out that that happens for every single packet that we pass through that particular domain. A solution approach that we have, or a solution proposal, if you go to the next slide, is, well, we take a secret, we split that secret into as many pieces as we have service functions, and then we distribute these individual pieces to these various service functions, and now we let the packets travel, and we pick up pieces of this secret as metadata as the packet traverses through the service chain. That means if I have a service chain with 4 individual service functions, I'm going to go split a secret into 4 pieces, and then at every single hop, I'm going to pick up a portion of that secret. And at the very end, I can either say, okay, I can reassemble the original secret, or I can't. Here now, a little example, we have 3 hops, and we take a pie, and we partition that pie into 4 pieces, and at every single hop, we pick up a piece of the pie, and later on are either able to reassemble the entire pie, or you're not. If not, well, something bad happened. And you can at least say, well, something bad happened and there's something going wrong. Now, coloring packets and ponying up pieces of a pie doesn't really work that well in reality. So what can we do in order to operationalize things in the network? If you go to the next slide. Well, what we do is we wanted to have something that is computationally very, very cheap, i.e. don't encrypt, because we want to go do that every single hop. What we ended up using is Shamir secret sharing. And that goes back to school math. If we remember school math, polynomials, a polynomial of degree n is defined, uniquely identified by n plus 1 points. So a line, 2 points, parabola, 3 points, and so forth. So what we do is, if you go to the next slide, we split, or we use a polynomial as the secret, and then individual points on the polynomial are the shares of that secret. That's exactly what Shamir secret sharing gives us. So if we have a service chain of 3 nodes, we need a polynomial of degree 2. We take 3 points on that one, and at the very end, doing Lagrange interpolation, you can either reconstruct the polynomial, check, or you can't, problem. And there is a beauty with Shamir secret sharing. It can be implemented very, very cheaply. So no cryptographic whatever. Yet it's secure. It can't be broken because it's very simple. Like if you miss a point, then you won't even be able to reconstruct any parabola, right? All you'd get is to a line. So if you look at this a little bit further in detail, you'll find, well, we would need a polynomial per individual hop. If you go to the next slide, that is difficult because we would need to go and provision a dedicated secret on a per packet node, on a per packet basis. That's hard to do. So what did we come up with? We take one polynomial that is secret and forever almost, and we take another polynomial that is per packet. And then we do the sum of the two, because the sum of something that is public and something that is private is again something that is private that will work. So one thing is secret and relatively constant, i.e. at least for a couple of years, and one piece that is per packet. And now, if you operationalize this entire thing, the question is how much metadata do you need to carry? In order to identify the second polynomial, we take the constant part, so the constant index of the second polynomial as a piece of metadata that we carry within the packet. And so It depends on the uniqueness of how many packets you can flag with a polynomial that way. What we ended up doing is a little bit of math, if you go to the next slide, where we say, well, if we would run at 100 gig and we would give ourselves 64 bits of metadata, we can survive roughly 3,000 years at full line rate at 100 gig. That doesn't mean that it's, well, 64 bits in all cases. If it's less metadata, you need to go and refresh more often. If it's more, then you need to go refresh less. But in average, I think it's a very workable solution if we take 64 bits of metadata in. Now, 64 bits of metadata, we need to go carry somewhere in NSH. If you go to the next slide, we need something to identify the second polynomial, so the one that is per packet, which is our random number here. And we need something, because we do the math on Shamir secret sharing in a cumulative way, we need another set of metadata, again, 64 bits. So overall, let's start off with 2 times, well, 64 or 2 times n, and we can carry it somewhere. We can carry it in NSH, we can carry it as NSH type 2 metadata. If you go to the next slide, which is something that we have specified, so there is a proposal, if you look at the drafts, the transport options draft, where we say, okay, this is how it can be carried, very straightforward as type 2 metadata. Next slide. Would be provisioned through some controller, and we today have an implementation in Open Daylight to do exactly that. So can be operationalized relatively easily. And the good thing is, from a data plane perspective, what it comes down to is 3 additions, 1 multiplication, and a modular prime operation on a per packet basis. So it can be done cheaply. So what's the overall context? If we carry metadata, just because the whole thing is called in-band OEM, I just also wanted to have 2 slides on what the overall context is. Jim, if you, so this is not our overall standalone, but one step further. So if you look at the bigger picture, if we carry metadata, and that's not only specific to NSH, so this is only for context. What we're asking for is basically, I want a code point for NSH type 2 metadata to carry these two identifiers. But if we carry operational data within the packet, there's a bunch of use cases that we can solve. And we're having a larger debate in RTG, WGG later on the week, where we can, or where we will make the case for carrying metadata within the packet or data records within the packet to help you with OEM operations. So not probe traffic, but tag all traffic in the network. That obviously helps with ECMP. It helps with the path verification that we just had. It helps us to do SLA checking in the overlay. So that's another discussion that you guys are having here. You can put geolocation data into the packet so that you understand where a particular packet went in the network, and, well, derive or apply policy on that one. So again, from an implementation perspective, what it comes down to, if you go to the next slide, it comes down to adding metadata to every single packet, and then you just got to go find a home in the packet for carrying that metadata. Metadata, that means node ID, ingress interface, egress interface, timestamps, something generic as GPS geolocation, maybe sequence numbers if your protocol doesn't support sequence numbers and you want to understand drops. And, well, you got to find a home for that. In V6, you can use an extension header. In VXLAN GPE, we can use an embedded protocol header for doing that. In segment routing V6, we have a policy element, or nowadays TLV structure. In NSH, well, we have type 2 metadata. So there's good homes in many protocols where we can carry operational information within the data packets. And if you go to the next slide, this is how it would look like. Well, the rendering doesn't come out with the coloring very nicely, but you typically have an operational domain where you use this feature. You see a plain packet coming in on the left-hand side. Then you, well, put out an additional header in, put an additional piece of data in between the header and the payload. And that might be proof of transit metadata like we had in the very beginning discussion, or it might also be on a per hop metadata that we are accumulating, where we're just putting path tracing information in, very much like traceroute, with the difference that we allocate the entire space that we need in the packet right up front, so that we don't end up with well, change of packet size based on a per path basis, which gives all kinds of troubles when it comes to PMTU and the likes. And then you start to update that information hop by hop. whether you're just updating the proof of transit metadata or whether you're also inserting path tracing data. That's obviously a domain-specific configuration and question. And with this, next slide. Well, I obviously appreciate feedback. All of us authors are kind of keen to understand what are you thinking about the whole thing. And if, well, you think that that's something useful that we want to go add to SFC, then, well, we probably need a call point from you guys. Thank you.
Yes. Hi, Greg Mirsky, Ericsson. Two questions. First, when you're verifying their transit, can you guarantee the order you traverse the nodes?
With the Shamir secret sharing, you can't.
So
you can only say this set of nodes was visited, not the order. We've been debating that to death with a couple of guys who are coming from the operational side, so largely these financial institutions, and they said, well, that's not too overly interesting. We have a different way on how to approach that. What you can do is you can do nested encryption in an iterative way, kind of composing an onion, so to say. But the problem with that is that you need chipsets that support AAS or something similar. So it's getting more expensive, but it can be done in a similar way. The amount of metadata that you carry is relatively similar.
right. So basically, because you cannot guarantee the order you traverse, and some service functions depend on the order. So
correct. So as I said, that's not the solution that necessarily needs to be there for all kinds of scenarios. If you have a scenario that is more demanding, that requires ordering, we would go for something like iterative encryption of a nonce. And then just say, okay, have the same method, right? You either encrypt iteratively in the right way or something wrong happened.
yeah. And second question on terminology. In your document, you claim that active OEM cannot be in band, that it's always out of the band.
Well, terminology is an interesting beast, and what you call passive or active, I don't want to even go there.
No, it's that's very simple. There is RFC 7799, which says what is active, what is passive.
Which is an informational document, yes.
Of course.
But anyway, well, anything is fine, right? So I wanted to give the thing a name, and if we find a better name, I'm all for suggestions for better naming.
No. The question is not the name, how you name your method. The question is why you state that active OEM cannot be in band.
Okay, fine, fair point. If you want to go and get that corrected, we can do that.
And then why active OEM cannot solve what you're trying to solve when piggybacking data on a flow, and that would not have that problem with MTU size limitation.
Fair point.
Yeah, I kind of, Stuart Bryant, I kind of worry about exactly the points that Greg raised, and they were the first things that came to mind when I read this stuff. It seems to me that you've got a partial solution for a sort of small element of the problem, and might be a lot better to try and find a solution that really solves the problem. I'm also kind of worried that your tiny fragments of secret that each party holds would be subject to some relatively simple crypto attack, and someone could inject somewhere else into the network, having pretended to go through those hops.
Well, I think from a crypto perspective, there is loads of proofs around Shamir secret sharing. So breaking it is virtually impossible, right? So that's safe. And given that we're doing everything over a finite arithmetic field, even against replay attacks, we're protected. So I think security-wise, we're relatively safe. Whether you want something that is generic and slow as the key solution for everything, or something that is relatively specific but can be implemented in a relatively lightweight way, I think I'll let people decide.
There's a question on the far side of the room.
Yeah, Dan Drutza. Interesting idea. And you answered my first question about the sequence. How do you guarantee that it doesn't go through multiple more than the hops you want? So is there something that you can actually determine that it had more than ABC hops that you colored there. And somehow unrelated question, do you have the ability to signal to turn it off? You know, you may want to turn these things on only for certain scenarios that, you know, are for operational reasons you want to, but in general, you don't want the overhead. So how do you manage the balance between these things?
Yeah, so a couple of points. So we verify with this that we transited a particular node. We don't verify that it went through all of the nodes in a particular network. So that means you dedicate and say, well, this is the set of nodes that I want to be verified. If there is more, we don't care. If there is more nodes that you care about, you want to go and make sure that they're part of the verification schema. So that means if there is nodes in between that got inserted, extracted, whatever, but they're not part of the schema, we don't care, right? And to the, what was the second question? Got to remind me again?
Turning off the feature.
Well, absolutely, right? So I think you're obviously free to go and say, okay, I'm going to go classify only these packets, need to make it, and will be kind of subject to checking what others are not critical. So maybe it's only my SAP traffic that I want to be verified, when I have verified and other traffic. Well, you're free to use a classifier, you're free to go and use a specific service chain for just that. I think there is endless options in that. So it's not, you either have to do everything or nothing, there's a lot of gray area.
Last question on this, thanks.
Ramakrishnan, Dell. So based on the secret sharing, I'm guessing this is right now worked out more as a solution within a single administrative domain, right?
Correct.
So are we considering expanding this work beyond that?
Interesting idea. We haven't really looked into that. So the key driver was financials and the guys who doing kind of service chaining in NFV land. And in both cases, we have a single operational domain controlled by a single controller so that you're completely in control of where you're distributing the shares of the secret to, as well as you're in control of what the verifier is, and you can secure the channels between the controller and the individual nodes. By the way, we have a reference implementation out in FIDO, BPP, and we're working on open sourcing the Open Daylight piece, so you can go and try it yourself.
Oh, okay. Excellent. And perhaps
we might even do a demo as part of Bits and Bytes, so if that kind of shakes out.
Yeah. Perhaps worth clarifying this in the draft. Just a single. Thank you.
Okay, cool. Thank you.
Thank you, Frank.
Thanks, guys.
Okay, next up is the overlay OEM design team from the Rowden area. I'm not sure who, Greg. Okay, thank you. Just let me know as you want me to go through the slides here.
Okay, yes. So let's go next. I think just by cutoff date of IETF 94, so the group was kind of exchanged, formulated their idea and the feeling that there are a lot of commonality and work being done in three working group, NVO3, BEER, and SFC, trying to address their OEM needs of different encapsulations. And then with the experience of working via the VXLAN and transcending traceroute. So there is some commonality of the problems being faced by different encapsulation layers. And after the presentation at 94, like injecting this, we came up with their design team that was under routing working group. And in Buenos Aires, we gave our first report on 2 documents that we started by that time. Since then, we added 2 more documents, and that's what we would like to present today and have your questions and discussion. Let's go next. So the charter was specifically to work on first the requirements and the gap analysis to identify existing solutions and protocols to the problem that we identify in the requirements document, and then continue work on practical solution, specifically on 3 encapsulations. It's in NVO3, They have three proposals, SFC and a beer. Next slide, please. So what's covered in the requirements? Next. It's a fault management, performance management, alarm indication signals, resiliency, and security. Next. So overlay OEM independent on a transport layer. Well, that's quite obvious. Then every node is a map. What it means that every node can be where we inject active test, and at the same time it could be an test point. Ability to do SDN, so which requires a data model, proactive and on-demand OEM, unidirectional, because most services are unidirectional, but at the same time, ability to do bidirectional if the service path is bidirectional. And ability to look from their overlay into underlay. That is a lot of interest, and as I see, a lot of work being done in SFC to that account as well. And path MTU discovery. Next slide, please. Okay, what is in the fault management? So the fault management is continuity check, remote defect indication, as a proactive, as on-demand, is connectivity verification, defect localization, trace route, and queries. At the same time, the proxy queries, when you want some other node to do the query for you and then report back to the sender or to the third party. Next slide, please. On the performance measurement, we do use the term as a passive method and not exactly as in RFC 7799, but we use it as interpretation that if the method is applied in a way that does not change the treatment of the packet by the network so that there is no impact on the data traffic, then it's as close to the passive as possible. And we do discuss in our solution document and gap analysis the use of method that allows that and what it requires of encapsulation there. Next slide, please. And obviously, OEM does have its own security considerations that will need to be addressed and looked at and discussed, and that's actually their topic that was first on the agenda today. Next slide, please. Okay, in the gap analysis, we looked at protocols that developed at IETF, and we tried to decide what can be reused for these three encapsulations. And from operators, it's very important that we do not force them to change their operational model. Next slide. So we looked at proactive continuity check, and then obviously it's a BFD in 5880, 5882, 83, 84. We looked at on-demand methods, similar like ICMP ping or LSP ping, and these are not directly applicable. Basically, that's a foundation, one of our proposals that we'll discuss later. Next slide, please. So we do have different variants of BFD. We have BFD for point-to-point. We have two proposals, BFD for multi-point and multi-point with the active tails. And we have now SBFD, which is more of their reflector or echo mode. And continuity check connectivity verification At the same time, it's not only a ping trace route mode, it's echo request reply. So, and it was demonstrated how can be used in LSP, in MPLS, with the DDMap information. So basically, when you have equal cost multipath fanning out of the LSR, you can request to know all the outgoing labels, which is your way of discovering your topology. So that is something that definitely of a lot of interest to the overlay, underlay mapping, and verification. Next slide, please. In the performance measurement OEM, we look at two different modes. So the active loss delay measurement and passive. Again, passive is not entirely in 7799 definition. As active at IETF, we have two candidates. It's two-way active measurement protocol and MPLS loss delay measurements 6874. After a discussion, we concluded that 6374 is more hardware friendly and a better structured. So the recommendation is to work on adapting it for their as active performance measurement in overlay networks. In passive, the alternate marking method can be applied in a passive way, and we have a work already started in a beer working group which demonstrates what level of support needed from the encapsulation layer, so this mark would not be affecting the forwarding and classification of the packet, so thus it will not change the behavior whether it's a packet marked or unmarked. And that's one of the conclusions of the gap analysis document, which saying is that in order to have passive performance measurement support, the encapsulation layer should consider allocating a field which can be used for the alternate marking method, but this field should not be really looked at and used for their packet treatment by the network. Next slide. So we looked at use case, how the BFD can work in SFC. Next slide, please. And the continuity check on SFP, and the question is, so what are we verifying, what we are monitoring? And their view is that we're monitoring their continuity of the path through the SFFs, not availability of their service functions. Next slide. So the deployment could be in two ways, either end-to-end or hub by hub between SFFs. Next slide. So in hub by hub, then the BFD sessions established between SFFs. So the question is it useful? And if it's useful, for what? Is it to trigger some protection switchover, to trigger some alarm indication signal? For us, it's an open question. We need your comments and feedback. Next, end-to-end case. So that's where their BFD session established between the egress and ingress of the switch function path, and it's encapsulation dependent, and again, what it drives. Because monitoring the proactively monitoring continuity has to serve certain purpose. Usually it serves their trigger switchover, protection switchover. What the resiliency, what the protection switchover story is in SFC. That's an open question. Next slide, please. in any case, there seems to be that we need to have some bootstrapping mechanism and to have out-of-band channel because BFD session is bidirectional. So if from ingress to egress we use the SFP, then do we, and what exists as a out-of-band channel? Next slide, please. So, yeah, so encapsulations can be different, and we do have examples in MPLS to use IP-UDP encapsulation or what's called an ACH encapsulation, which doesn't have IP-UDP header. Next slide, please. Yeah, we can skip this. Yeah, altogether to the next slide. Telemetry, yes, at least for now, we're considering the telemetry being in the scope of our work and not on defining the format of telemetry itself, but defining the transport that collects the telemetry. And it could be done using echo request reply. Next slide. Yeah, let's go next. Let's speed up a little bit. Okay. Next. Yeah, next. Okay, so yeah, we talked about it. Okay, next. Okay, so now this is the first proposal is that after the layer encapsulation, we have to use overlay OEM header, which is constructed of version number, message type, flags, and the length, which describes the whole OEM packet. Still, we're debating whether 32 bits is sufficient or there is some use for additional 32 bits for their some indications of functions that being included in OEM packet. Okay, next slide. One of the possible applications that we used and is to have the timestamp that follows the OEM header, so which makes it more hardware friendly for the hardware assisted timestamping in case we want to measure round trip delays. That's why there are 4 timestamps, and because we can use a different time format, NTP or PTP, so there is indication of the timestamp format of the sender and responder. Again, this is open to discussion and I appreciate your feedback. Next. Okay, so now it's echo request reply. So the control format of echo request is very similar to those familiar with the LSP ping. It doesn't have a timestamp because now we're taking it out of there, and it has message type, the reply mode, because the reply could go over out-of-band IPv4, IPv6 network, or go over a specified control channel. The sender handler, which is effectively test session ID, and the sequence number just to use it possibly as a synthetic class measurement method. And then the TOVs. The TOVs will provide you with abundance of different functions on defining the return path or defining the functionality for their query between overlay and underlay you want to get. And at the same time, it will be used in the echo reply to deliver this information back to the sender or to the third party. Next slide, please. Okay, so that explains the format. Next, please. Okay, so there's a lot of work to be done, and we appreciate the comments, questions now on the list.
Okay, open for any questions. None? Okay, good.
Diego Lopez, it's a general reflection more than a question on precisely many of the things that you're mentioning here. Essentially, if you look at them, are bringing me back to the discussion for security. Because, for example, timestamping at the end can have security applications as well. And I was thinking that if the same kind of effort that we're doing here, precisely, and exactly the same, is taking and defining a set of fields that can be applied for OEM, we could do exactly the same work. I'm not volunteering for that, but I would say in the same way, and we will be addressing precisely and proposing the security requirements. Call it, I don't know if at the end this is going to be called OEM metadata or something like that. So I don't know if that is what you have in mind, but looking at it, I would try to go the same, exactly in the same way.
Mm-hmm.
And that would imply that the famous security consideration section precisely would say that there is a definition of the metadata that is applicable, and hope that will satisfy the security area people.
Yeah.
Sorry, nothing particular.
Okay.
Ramki Krishnan Dell. So I do see a lot of similarities between other drafts. For example, the one presented on the path verification, that's a specific solution, of course, the broader framework. And I think there are also other drafts right now in SFC timestamp and also work having in ops, happening in ops around overall telemetry. So what's really the strategy? I mean, are we thinking finally is ops the home, or somewhere else is the home for all these drafts, or just wanted to get some thoughts.
Yeah, I agree. There was a lot of similarity, and what was concerned, and actually what was their trigger to start this discussion on common OEM like 2 meetings ago, was that similar problems were solved in all these 3 groups through different methods. Okay, so again, which proves that yes, we are trying to address the same similar problem, but approaching it differently. So then the question was that, okay, perhaps we can do it in one place, and that will work for everybody.
Yeah, one thing, just a comment from my side. We have an OEM framework document in SFC right now that has basically been dormant for a long, long time. And again, just like the security, we need people to stand up and actually push these things through. And so one of the things that I'd like to see, and it may already have happened, but at least a liaison between the people that are working that draft, or at least started to work that draft, and what you guys are doing.
I might be mistaken, but I think that there is a certain cross-pollination of people who worked on the framework OEM.
Yeah, which is excellent.
SFC, and
I just want to make sure that's
in
happening.
a design team.
Yeah, excellent.
So Joel Halpern, Carlos and I were talking about picking up the pen, getting the document moving again. And yes, I talked to Greg a lot, and I know it's important.
Excellent.
Yeah, Early Atlas, just to answer Rami's question a second, is the idea with doing the design team was there's an opportunity. It seemed like we could get at least, hopefully, some sorts of common packet formats, and then different encapsulations if needed, could have additional TLVs for different concepts and ideas, trying to broaden the discussion now, see if the direction that they've been going seems interesting, what other problems, like the presentation we had before, or some other pieces, how broad is the work, and we can't sit on it forever. We need to actually, if if this looks like it is helping solve SFC's problems and the working group wants to go in that type of a direction, that can help inform how we structure the work moving forward. I am expecting the design team's mailing list is going to become open after this so that we can have more discussion and move forward.
Yeah, it's great. So, and also one of the things that's happened is, we have documents already that are already going in and defining how to do SFC traceroute, for example. And the reason is that, this stuff is being deployed and implemented, and people are kind of putting in the stuff that they need. So I need to make sure that we're liaising with those people as well. To make sure that we pull this together. I know Joel and Carlos know all about that, so it's in capable hands. But that's excellent. Thank you, Greg.
Thank you.
Okay, before we move on, I just want to check just an admin thing. Where's the blue sheets? Can the people that have the blue sheets stick them in their hand? Is anybody not signed the blue sheets? Can you pass them to any hands that you see and pass around? Thank you. Okay, so next up is SFC performance measurement. Gorek, yep. Let me, I'll pull it up for you. Just let me know as you want me to go through the slides.
Hello, everyone. My name is Gaurav Agrawal. So I will be introducing our idea of the performance measurement for SFC. So as the overlay OEM is already there, we come up with this idea last year. So now we can see how we can integrate with the overlay OEM. Basically, we need to see how it can be generalized. So that is what we will look into in the future. Okay, so the agenda here is, first we will be looking at the problem statement, what we are trying to address with this draft. Then we will be moving on to the requirements, what are required to address those problem statements, and at the end, the mechanism, what we are proposing. Okay, so there is some formatting problem anyways. So as we all know, like for a proper operation of any network, we need to continuously monitor that network, and we need to ensure that any fault happening in the network, we quickly identify, quickly locate, and we are able to quickly fix that problem. So now if we look at the SFC network in that sense, it's the fault can happen at any place in a service function path. The fault can happen with a particular SF. The fault can be there with a SFF. The fault can be there with a connection between a SF and SFF, or between or with a transport network itself. So that is about the locations of the fault. In the same lines, the faults can be there because of the multiple reasons. It can be because of the machine going down, it can be because of overload conditions, or it can be because of some error conditions, etc., etc. So basically, we need to handle all these problem statements. So now if we look at the traditional transport level mechanism, what are available, those are not good enough to solve all these problems. So now the questions what we have with us is how to identify that the service failure has happened and how to quickly localize the fault. Not only the failure scenarios, we also need to see that the service should not be deteriorated. So we need to quickly identify that the service deterioration has happened, and we need to localize that issue also. One more important requirement is how we can ensure the customer SLAs. So these are some of the problem statements. To handle this, we come up with some of the requirements. So to handle these problem statements, what we need is a mechanism via which we can have a connectivity check, we can do a trace, we can do a loss measurement, we can do a we can do a delay measurement, we can do a jitter measurement. So all these are required. One important point what we need to see here is any mechanism which we are proposing should be capable to monitor a particular SF, a particular SFF, or a set of SF and SFF, or any segment in a service function path or SFC as a whole. So we need to monitor each and every piece in a service function chain. So that will be required. One more important requirement what we look into is the capability to monitor not only the coarse grained flows, but also the fine grained flows. Say for an example, in a service function path, we are having multiple types of traffic, maybe a voice traffic, video traffic, or a data traffic. We wanted to only monitor a video traffic. That should also be possible. So there is, for such requirements, we need to monitor even fine-grained flows in a service function path. Another requirements, which I think already covered, is like it has to be continuous also, on demand. Both options should be available. And again, the active measurement, passive measurement, hybrid measurement as per the RFC 7799 should also be available. Also, we need to ensure that in case of ECMP scenario, the mechanism works fine. So these are some of the requirements what are important in terms of SFC performance measurement. Can we move on, please? Okay. So the mechanism what we are proposing is like more inclined toward the SDN era. Basically, there are 4 entities what we are proposing. The first is the measurement controller. Basically, the job of the measurement controller is to control and coordinate the set of service measurement functions. And it is a responsibility of the controller to program the PM instance at the measurement classifier. So basically, the PM instance will have the detail like the flow classification rule for the performance measurement flow. With the PMF identifier, we have introduced one unique PMF identifier as a part of this. This is specifically done to for the fine grain flows, basically. In case of coarse grain flows, this will not be required. Then it will be having a list of MAs, over which the performance measurement has to be executed with the PM type, what type of performance measurement we need to carry out. And it will be having some other details like the window index and the PM schedules. These details will be there in the PMI, basically. Now the second entity is the measurement classifier. The job of the measurement classifier is to classify packets based on the measurement flow classification rules and encode the PM info in the packet. Now, this PM info will have the details like what all MAs, participating MAs are there for a particular PM instance. So now the SF and SFF will check whether they are one of the participating MAs. If they are one of the participating MAs, they will carry out the measurement, they will collect the information, and they will send the information to the collector. Now it is a job of the collector to correlate the information and give the result. So this is the proposed mechanism for this particular draft what we have proposed. We have also written 2 more drafts where we have given the implementation specific to NSH for the packet loss and the packet delay measurement. So this is how it will look like. It will have the PM types. So we have defined multiple PM types in these drafts for hop by hop, for end to end, for particular segments, and the measurement window index to identify like there is no ECMP, there is no problem in the ECMP scenarios. And the MA identifiers are basically required for the scenario when we wanted a particular MS only to participate in this particular measurement. If it is hop by hop and end to end, the MA identifiers will not be required. So these are the references. We are also doing a reference implementation in a ONOS controller for this particular these particular drafts. Yes, that's it from my side. Any questions? Yes.
Yeah. Hi, Greg Mirsky, Ericsson. A couple of questions. So first, on this reference model, and you probably can look at LMAP framework that defines the reference model for large performance measurement in large-scale access networks, which is very much like what you propose and has a controller, measurement agent, and collector. And it does have a data model already, so with the schedule and everything. That's the first thing. The second thing, when you define the performance measurement of service function, where is your measurement maintenance point? So what you're measuring? You're measuring performance between SFF and SF, or you're measuring performance of the service function application. So basically you are measuring on ingress to the service function and egress service function.
Okay. Basically, we have three different options for that. We can do hop by hop. So in that case, we have introduced something called as MA identifier in that scenario. So MA identifier will indicate basically what all MAs are the participating for the particular performance measurement. In case of hop by hop and end-to-end thing, the PM type itself will indicate that each and every hop has to participate, or it's only the end-to-end guys. Now, with the MA identifier, we can put this information that a particular SF or a particular SFF has to participate in this particular measurement.
Okay, when we talk about SFF, okay, what particular, okay, not what, where you are taking the timestamp? Okay.
Timestamp is not carried in packet. Basically, once the SF or SFF identifies that they have to do the performance measurement for a time, they will record the time for the packet coming in and the packet going out, and then this time they will store within themselves and they send it to the collector. So now it's the job of the collector to print the complete report.
Okay, so basically you're measuring their application.
Basically, it's a SF performance delay for
No,
the
it's not SF, where you are measuring application, because if you're taking the timestamp on egress to the service function, in egress of the service function, you're measuring application. You're not measuring service function.
Basically, okay, what we are trying to say is it's basically for a data path, we are doing it.
It's not data path. You are measuring performance of application, which is interface to the service function.
Okay. We'll have to, I'm going to have to cut you off, and we'll have to take that one offline. So sure. A last question in the interest of fairness to the other presenters.
Ramki Krishnan Del. So you're mentioning that you are doing all the analysis right in the controller, but there are other scenarios like, virtualization of network functions where you need to consider where the analysis happening outside of the controller. For example, you can do joint analysis of compute, network, storage. So you need to keep interfaces open for that. And in fact, we have several drafts in NFE research group towards that direction.
Oh, sure. Thank you.
Thank you.
Thank you.
Okay. Let's see. Next up is the hierarchical SFC. Just let me know as you want me to go through the slides.
Okay, good afternoon, everybody. My name is Shinsuke Homa from NTT. Before the presentation, there is something I have to tell you. Today is my birthday. So thank you very much. Thank you. So please go easy on me. Okay, in this presentation, I will talk about the overview of hierarchical subfunction chaining, or HSFC, and the update point since the last meeting in Buenos Aires. And then Dave, who is the first author, will explain the document status and next steps. Okay, first of all, I will explain the overview of HSFC. HSFC is an architectural proposal to enhance SFC architecture by dividing a network into multiple layers. HSFC defines IBN as a function to define a network. IBN has several roles in each layer. In the upper layer, IBN conceals a subdomain from upper domain and behaves as a service function. In short, an IBN and concealed subdomain look like a service function from upper layer. On the other hand, in lower layer, IBN has roles as classifier and SFF for lower level paths. and groups lower level and upper level paths, like the figure in the red box on the right side of this slide. Then why HSFC is needed? In large-scale networks, such as carrier-grade networks, there are millions of hosts and thousands of subfunctions, and a centralized control of entire network will cause serious complexity in management of SFPs and subfunctions. We expect that HSFC will be a solution for such problem. Next slide, please. So then I will explain the main changes since the last meeting in Buenos Aires. We added 2 new proposals in this update. First is a new path grouting mechanism of IBM. And second is about applying HSFC for NSH unaware service functions. In the following slide, I will explain them. Next slide, please. So firstly, I will explain the new path grouting mechanism. As I mentioned in the previous slide, IBM has a role to glue lower level and higher level paths. And IBM must return the packet from lower level path to the appropriate higher level path. The current document describes 5 methods to achieve it. And the last one of the list is the new proposal in this update. So in this slide, I will explain the new proposal. It's called hybrid approach. In hybrid approach, IBM saves NSH information with ID and retrieve the NSH from the ID. This figure shows the processes of hybrid approach. When IBM receives a packet from lower level path, IBM saves the NSH information with an HSFC flow ID and inserts the ID into context header 1 of lower level path, lower level NSH. And then when IBM receives a packet from lower level path, IBM refers the context header 1 and retrieve the appropriate NSH, like this red right side red box. Next slide, please. So the advantages of hybrid approach are listed here. Especially hybrid approach beneficial in terms of scalability and availability for such functions, which changes the origin packet format, such as NAT. Also, hybrid approach can has little or no impact to components of lower level domains, because this approach requires a change of just only one context header. It's a large benefit. Second slide. Next slide, please. So secondly, I will explain applying HSFC to NSH unaware service functions. We expect that HSFC can be used to facilitate providing service chaining in a network where NSH aware and unaware service functions coexist. For example, in a period of transition from legacy service function to NSH aware service functions, or data centers supporting multi-tenancy are considered as such situation. SFC proxy is defined as a function to apply NSH unaware service function to SFC architecture. However, preparing many SFC proxies would be heavy burden for network operators. We expect that this HSFC will be a solution to such problem. And in this usage, IBM converts NSH forwarding to other forwarding techniques such as 5-tuple-based routing with OpenFlow, like this figure. So in this usage, this method can be used because this method doesn't require to use NSH in lower level domain. Especially the method using unique lower level path upper level NSH is better because this method can be used for service function changing the within packet format. In addition, in this usage, IBM may be required to have a function to transform packet to appropriate format. For example, some legacy service functions use network topology information to identify subscriber information. So, for example, IBM may be required to create VLAN or other L2 information if subscriber information is conveyed as metadata in upper level domain. That's all my part, and the following slide Dave will explain.
Okay, so there are some things that we would like your help on, your advice. The document covers several different mechanisms for restoring packets to the upper level path. We've got, I think, about 5 suggestions. So, we're wondering whether we should actually be, settling on a subset of them or recommending one. Our current view is that this is a deployment choice. And that's what I think we'd like to leave that. Several of the methods have advantages and disadvantages, and you may want as an operator to pick the one, or as a developer of this solution to pick the one that's best for you. So when you ask your questions, if you have any feedback, or if you read this and let us know what you think on that subject. Next slide, Jim. And another thing we're wondering about is the in the appendices we have some use cases trying to explain how why we've been motivated to make this solution. So we're wondering whether that should be moved into the core part of the text, or whether it's fine as it is. We think it's okay right now as appendix, but your feedback on that would be welcome. And next slide, Jim. So as far as next steps go, you hopefully know that there's been a call for adoption for this document, and thank you all for your support. It's got quite a bit of support for it. We would, I don't know if Jim has any comment on that, but we are saying that, if we get this adopted, we're committing to, working quickly and getting a stable version done. And we're hoping to recruit some people who haven't reviewed it yet to review it as well. Okay. Anyone want to raise their hand now and say they'll review it?
Well, I'm hoping, multiple people will look at this document. There's a lot of, frankly, there's a lot of interest. And we're in the working group call for adoption, and, there's been a lot of support for this document. So thank you for all the work you guys have done. And so this, it's looking like this will become a working group document that we're going to work through. So please liaise with Dave and make sure, do good review of the document, and let's move this forward.
Yeah.
And you can stay at the mic, Dave. because I think you're up next on the next topic.
Okay, I'll stay here. Any questions on this one?
Okay, so we're just, this is the last topic. So Dave, go ahead.
Okay, so this is talking about draft Peno SFC packet. We put up a new version of it with some additions. Just to remind you, go to the next slide, please, Jim. Just to remind you of the problem statement here is that many service functions need to inject packets into the network. And in particular, the particular case we're looking at here is responding to a packet when we haven't seen the packet going in the other direction yet. So there are some, various different kinds of devices, like a firewall may wish to respond to a SYN packet with a reset packet, or a proxy may wish to respond to a SYN with a SYN ACK, to create a half connection. Anyway, there are a lot of different places this comes up. This document addresses, how do you handle that? And there are a few different ways we talk about how to do it. So next slide, please, Jim. So Ronaldo talked about this a couple of meetings ago, but we've got a new version. I read over some. One of the changes is that one of the methods required 48 bits of metadata. There's a new approach which only requires 32 bits of metadata. And also there's sections on dealing with metadata, which I think was previously, there's some hand waving about. We tried to make that more concrete. So next slide, please. So these are the different ways that we've talked about handling the reverse path. So the first method is that there's explicit configuration in the service function. So each path would have a configuration for what the reverse path would be. In fact, each path identifier and index would have a reverse path and index configured. This requires configuring the service function from the controller. The second one is, we don't really like the idea of configuring the service function, so let's configure, the SFF already has a lookup table, so let's put the information there. And there's a mechanism described where the service function can ask the SFF to reverse the packet using an OAM protocol.
No, I'll wait.
You'll wait, okay. The third method is the classifier adding some metadata to the packet that lets the service functions know how to reverse the packet. So this is like when a service function needs to send a response packet, it's got enough information there that it can do so. And I didn't explicitly say so, but I think everyone here realizes that the problem here is that we don't have symmetry in the path identifiers, right? The path going one way is not necessarily the same as the path going the other way. So number 4 is what we call algorithmic approaches. And these are where there's not configuration and there's not metadata. It's just that there is math that you can do on an identifier and an index to figure out the opposite direction path and index. And this is done by choosing your paths, identifiers, and indices carefully. So next slide, please. So I just did sort of a matrix here of what the requirements are for the different approaches. So as I mentioned, the first one, requires control of the SF. So this would be part of what was identified as the C3 interface in the control architecture. The second one requires changes to the C2 interface and also requires OAM protocol. The third one is where we encode the metadata. That's one of the things that's required is what we we require symmetric path. Now, the document hopefully describes this well enough, but symmetric path means, for example, if one direction is service function A, B, C, the reverse path is service functions C, B, A. You can't have unidirectional or reclassification and things like that. So that's one of the requirements of that approach. And it also requires the classifier to be aware of path reversal information. And I believe there's also, you have to choose your paths carefully. Now, there are two different ones we identify for the algorithmic approaches. One is where you give your path identifiers are related. For example, forward path 0, reverse path 1. Use one bit of the path identifier, or could be the upper bit, to identify the direction. And then there's some math that you do on the index to reverse it. And 4B, sorry, that was 4B I just described. 4A is you use the same index, the same path identifier in the SPI is the same in both directions, but you carve off a different index range. So one direction will be allowed to use indices like 0 to 127, and the reverse, and the other direction will be allowed to use indices like 129 to 255. So even though it's the same path, because we use same path identifier, because we use different indices, it doesn't confuse the SFF. Anyway, obviously you have to very carefully orchestrate these though. Okay, next slide, please. So currently, the document recommends the flip path ID mechanism. I believe this has been implemented. As I said previously, it does require paths to be assigned in pairs. It does require symmetry. The document also talks about how, and I guess this would be a requirement on the SFFs, it has the concept of a no-op entry, which you can use to create symmetry. For example, if the one direction is A, B, C, and the reverse direction is C, A, you can, in the reverse direction, create a no-op where the B should be, and it allows the, decrement the index and forward it without actually visiting a service function. Anyway, that helps create symmetry where there might not be. Also, we've been experimenting, at Sandvine with the same path ID disjoint index spaces, and it seems to have some nice properties as well. It's very closely related to the other one. Sorry, Jim, I guess I should have gone on to the next slide when I talked about the no-op. Basically, you know how the SFF has a forwarding entry. You look up a path identifier and an index, and it tells you the next hop. We see this as just, you can add a no-op as the next hop, which just means decrement the index and look things up again. Okay, hopefully I'm not going on too long here, but also we added sections on metadata here for, because of course the problem here is when you inject a packet, you also have the problem which metadata to insert. So there are a number of different ways, and I've mentioned these on the list before. I don't know if I can go through all of these.
You have 1 minute.
1 minute, okay. So I'll gloss over these, but some of these types of metadata actually don't work for, I was looking them over today, they don't work for reversing the packet. For example, if a metadata is only relevant to one direction, you can't keep a copy of it and you can't put it on the packet for sending it back again. But other types you can. For example, if it's a property of the bidirectional path, it's quite okay to put the metadata on the path. So this comes to other questions I've been raising on the list about what, and others as well have been asking about metadata, how to what are the semantics of different kinds. And I guess we'll go on, Jim, to the next slide. I think this is the second last one. I was wondering, can you let me know, raise your hand, are you encountering this problem, path reversal, when developing service functions? See a couple over there, 3. And you have different solutions than we did in here? Similar? Okay. So interested to know your feedback, whether these works or whether you have other ones. Anyone, also interested to hear what class of service function you're working on. Next slide, please, Jim. Yeah, so the authors of this, we think this solves a really important problem. We think it needs to be discussed, and we're asking if the working group will adopt this and hammer out the details and make it clear how these service functions are supposed to work, and may impact the control interfaces, may impact the SFF. So we're asking if the chairs would consider that.
Okay. Yep. Questions?
Okay, Greg Mirsky, Ericsson. So I just wonder, you mentioned that, or you characterized this as a case of bidirectional service path. Bidirectional, usually when you have injection of the traffic from 2 sources. So I just wonder, maybe this is just a case of circular service path, and you try to optimize how much of the metadata you program. So rather than program the whole path explicitly, which is a circular, you define some turning point and say, okay, from there we can calculate our return path because we need to go back.
But it's, I mean, I don't know if circular is the way to describe it, but the way I see it is, if we have a normal path that would go functions A, B, C, if we go A, B, and B wants to reply to it, we want it to go to A, B, and then the response needs to go back to A, and then leave the network. Or A, B.
Simplest example is if you have a multi-element service chain, in the middle of it, there's a TCP proxy, and it's doing ACK synthesis, and it goes and sends an ACK back, and that's not circular. It's, whoops, I got a new packet that I've invented, and I have to have the metadata to put on it to cause it to go back, and that's a real case. And
that is a case very close to OEM, right? And no, but the question is, so how important that you traverse this nodes that you traversed before, rather than using out of the band channel?
If the traffic is supposed to see the service chain, then the traffic is supposed to see not all synthesis cases, and not in all operators do you need to do this. But in some environments, the reverse traffic needs to. Now, having said all that, justifying your work, and I appreciate all your efforts, I was listening to your presentation and scratching my head. I think we may be trying to do the impossible, and the answer may be not to. Because if it hurts to do this, maybe we shouldn't. Because when I started thinking about all the metadata cases, and you list some, but in fact, for some things, it's not even the metadata type that tells you it's on this flow, we need to do it this way, on that, we need to do that way, for this service function, we need to do this, or for this other service function, we need to do it differently. And I stare at it and go, you're going to need to have control, configure the service function to do the right things. And that's out of our scope. We don't need to standardize that. I have no problem with recognizing the categories you called out, and where the categories apply, generally telling people about them in the TLV draft. And I have absolutely no problem pointing out to people that generating reverse packets and inserting packets into a flow, which also comes up, are complicated problems that service function implementers need to think about. But I'm not sure there's something to standardize here. This is clearly a real problem.
Are you talking about metadata in particular now?
Also about SFPID. I'm really nervous about trying to standardize how we do the SFPIDs so that the reverses can magically be taking place, because frankly, There's so much else that's going to have to be set up that it's trivial compared with that to configure the service path ID you need to have. You need to tell them which interface to send it over even. I mean, most of these boxes have multiple interfaces, and you need to be able to say in some way that means that's meaningful to him, for this traffic, you got to do this, and for that traffic, you got to do that. And so the SFP ID, you know, you might as well just configure that too, because it falls out as cheap when you do the rest of the problem.
Well, I think though, the way this is set up is, the way we've talked about it is, you know, if an SF can send a packet to its SF, to any SFF, it should be okay. Because the ultimate destination of that packet's encoded.
I don't think with what usually is being set up in most SFFs, that's true. Unfortunately.
There are extra requirements to think about.
So, Ramki Krishnan Dell, so there are possibly other ways to solve the problem. One of the things we do is just say that, hey, we just terminate the service chain and initiate a new one, and it's all handled by the orchestrator. So that way what happens is, any of the cases where you're terminating the application, like TCP proxy, HTTP proxy, you don't get into this trouble. So what I'm saying is there are other ways of solving this problem too. So that said, you know, adding to Joel's point, should we go down the standardization path?
I'd really be interested to hear other ways, like if you can talk about those. I'm sure we've missed something, but please help us.
Sure.
But you know, the service chaining is, you know, go from, say, first element is a NAT, then you go to a proxy, the proxy answers, it has to go back through the NAT in the reverse way on the same flow. I mean, these are, if you want to generically chain things together, you have to get them to go back through the correct elements. But
30 seconds, yeah, we'll have one more question after this.
I'm having trouble understanding that, so.
Yeah, we can take it offline, so we need more conversation.
Paul Bodger.
So last question.
So I'm Paul Bodger from Hewlett-Packard. You know, I just had to comment because of Joel's comment. I think if you're running a service chain, you do run into these reversal problems for a lot of applications that are doing layer 4 and above service functions. And I think we are not doing the industry any service if we don't specify how to do that. Because what happens is that a service function writer that is going to be chain aware ultimately needs to know how to do this. And if we don't tell them, then we're not going to get any standardization at all. We're just going to get a hodgepodge of incompatible equipment, which is not going to suit anybody in NFV or anywhere else. And so I think this is something that really has to get standardized. Anyway.
Yeah. And I think you raised the point about the layer 4 and above. It is, I think, a particular problem to those kind of stateful devices that are looking at the connections. And I agree, like if you don't do something about this, there's a smaller class of service functions that you can have. You just rule out certain applications that can be put in that way.
Just the plethora of really useful chains all end up with having some L4 and above.
Okay, last question.
So this Christian Koenig, F5 Networks, probably to give some context to the problem is that when you, for example, in a service function act as a TCP proxy, what that means is that you first initiate, particularly looking at the F5 implementation, the client side. So we as a service function see a SYN, right? And we send a SYN act back. The server side will not be up at that time. So we need to know where to send the traffic back to. So further on, we will establish a server side. So in order to answer then the suggested path of that will be a different indirection. It needs to follow the standard path as following. So there are two problems. We need to have a way to determine how the service path ID gets derived for the return path. And we need to know how the service index gets derived for the return path. Because I don't have that a priori knowledge to render then back the service index from the return path as well, right? So I only have the ingress return path. I don't have the return path for egress, right?
Yeah.
That's exactly the problem we're trying to solve.
So going to wrap it up here. Has anybody not signed the blue sheet? Okay, and where is the other blue sheet? If whoever has that could pass it my way, that'd be great. And thank you all for coming. Thank you. Hey,